Good day, good people. To this video, we will be dealing with the most important concept of ODE. It's actually the application of ODE. Many students cry about this this chapter because it's hard to analyze and you never know what to do. And then they also forget that maths is maths, even if you don't understand English well. But then if you are able to deal with what is given, it's going to be easy for you to actually kill the question. But then what I know is that it's hard to actually find the exact answer in this kind of a question. So that is why most of students who are very intelligent, they struggled getting 100% in their exams because of such questions, right? So now what you need to know is that the basic formula or the basic equation that you have to do, you always have to know, is that you did separable differential equations, you did direct differential and all. So that means now you having that knowledge, that's when you're gonna be able to deal with this. And it's the one that was actually introduced by Isaac Newton. It's just this, right? So you also have to know this, right? So this one is the room temperature or the ambient temperature, right? So this can be any temperature that you come across in your equation, right? And then this one is the rate of change, right? So sometimes they can tell you that the rate of change of this equation is 5%. So that means now you don't need to be looking for K. You just have to know that, okay, now that I have a rate of change, so that means it's going to be easy for me to solve the equation, right? So now if you are having something like dt over dt is equals to kt minus ts, or ta, some say ta, right? So now you have to do direct integration, actually separable equation. So that means it's dt divided by dt. No, you just have to do it because we don't have enough paper. So let us just do it here, dt, right? So now you have to divide both sides by t minus ts. It's now when you are looking for the equations to solve whatever, right? It's when you are solving for the equation. So divide by t minus ts. So now it's dt over t minus ts is equals to k dt, right? So now you have to do direct integration. So it will be ln of t minus ts is equals to kt, right? Then after that, you just have to know that when you are dealing with this kind of equation, are you aware that solving for t, you're gonna say this, right? Because this natural log is just equals to log ex, right? So now we're converting from log to the exponential, right? So that's how it is. Now t is equals to e kt plus ts, right? As in ambient, right? So that's how it is. And sometimes when you're dealing with it depends on the question that you're dealing with. Sometimes you'll find that here there is negative, sometimes you find that here there is positive, due to, if ever, this one is the one that is subtracting, right? So it depends. So don't worry about that misconception. You can just get it right if you did it this way, right? So now that means here you're gonna put in room temperature, then here you will put in the time that you can be given, right? So now we're gonna dive into the question, or let me just do another equation for you guys so that you can also know the one that deals with population. This one deals with the temperatures, whether it's heating or it's overheating. Now let's talk about this one. There is the one that is talking about the population growth, that is just dp over dt is equals to kp, right? It's just like this. So now how do you actually end up with the equation, right? So now here you have to say dp is equals to kp multiplied by dt, right? So now this one went that side, right? So now it's dp is equals to kp dt. So now you have to now apply, no, you don't have to apply now, because you have to divide by p so that it can come this side with a separable differential equation. So it's dp P is equals to K dt, right? So with that, you have to apply direct integration. So direct integration. So here it will be ln of P is equals to KT, right? So now we have to find P, right? We have to find the most population. Then from there is the power K. Don't forget that here there was plus C because we are integrating. So we just have to say plus C. So that means here we have KT plus C, right? So when we have KT plus C, we just have to say PT is equals to EKT e to the power C. It's one thing when we're talking about that rule of exponential rules and so on and so forth. So it's one thing. This one is equals to this, right? So this one is a constant, right? So constant, we can say constant is equals to anything that we want, right? So in this concept, you just have to say it's equals to P0. You can say EC is equals to PO. It's the same thing. You just have to put any alphabet. So PT is equals to PO multiplied by EKT. So this is now our equation. So now when we are given a equation that is talking about population, right? So that means now this is the initial population. This is the initial population. This is the rate of change. This is time, right? So this is the total population that can be needed, right? That's it. Now let's look at this question that I prepared for you. Let us look at this question that I have prepared for you. Now, let us now read the question. A population of JHP Johannesburg grows proportionally to its current population. The initial population is 5,000. The initial population is 5,000. I know that to the equation that I derived for you lately, I told you that PO is actually the initial population. Now, dP over dt is equals to 0.04 population, because now let's see, and it grows with 4% rate per year, right? So now this 4% now simplifies your thing, because now if you didn't have 0.4, so that means it was going to be just dP over dt is equals to kp, right? So now this k is this, right? So it is simplified because 4% is just 0.04, right? So now let's go to the first question. Find the equation to model the population. So how do we find this kind of an equation? We just have to put it here. dP over dt is equals to 0.04 p, right? Right. So now what is it that we have to do? We have to do our direct integration. So we just have to say dP over, now it's equals to 0.04 p multiplied by dt. Then to this one we divide both that by p. So we divide both that by p. It's gonna be dP over p is equals to 0.04 p. No, not p anymore, because it's cancelled. So now it will be like this. So we have to integrate this. So it's going to be ln p is equals to 0.04 t, right? So after it being 0.04 t, it's now going to be p is equals to ln 0.04 t plus t, right? Plus c, right? So now p is equals to POE 0.04 t, right? Using that method that I just said now, that this one is just equals to E 0.04 t multiplied by E and C, right? It's just that method. So that means now this is how to find the equation that we have to use to can deal with this entire question. Now, determine the population after 2 years, right? Determine the population after 2 years, right? So now, determining the population after 2 years, we just have to use the equation that we have. We have the equation, we have the exponential growth equation. So it's t, it's going to be just 2 years. What is the initial value? It's just 5,000. Then E 0.04 multiplied by what? By 2. Then from there we solve for the answer. So it's 5,000 e to the power 0.04 multiplied by 2. So that means it's actually 5416.4.4. So this is just the population, right? This is the population after 2 years. Now let's now go to the third question. How long? Immediately you hear this in each and every question. Immediately you hear long, so that means they are talking about the time. How long? They are talking about the time, right? They're talking about the time in years, the time in minutes. So now it's just the time, right? They didn't specify, so they just say how long it will take for population to double. How long will it take for the population to double? How long? So now the population that we had is just 5,000, right? So how long will it take for it to double, right? So now we have the population, that is this one, from the initial, from the given. And many people would have taken this, right? This is not the population we're talking about, right? So this one, we just talked about the population that we had after 2 years, right? So now they need to know how long will it take for this population to double, right? So now we have to say 2 multiplied by 5,000. This is equals to, right? So it's 10,000. This is our population. The doubled population, right? So now we have to say PT is equals to PO e to the power 0.04 T, right? So now it's 10,000 is equals to 5,000 e 0.04 T. So now we have to solve for T. We have to solve for T. So it's the easiest one that we can do is just multiply by 0, multiply by 5,000, divide by 5,000. So here it will be just 0.04 T is equals to, it's equals to 10,000 divided by 5,000. So it's 2. So it's 2. So now from here we need to solve for T. So that means we just have to apply natural log here. 0.04 T is equals to natural log here. So that means we're gonna take this to the front. That's meant ln of E is equals to ln of 2. Then from there we're gonna just do you know that ln is 1, right? If you don't believe me, I don't have a problem. I'm just gonna show you. So that means it's 0.04 T is equals to ln of 2. Then T is equals to ln of 2 divided by 0.04. So T is equals to ln of 2 divided by 0.04. We'll have 17. So now that means it will take 17 years. It will take 17 years for this thing population to actually double. All right, so that's it, guys. And then always, guys, you need to always like, share my videos and comment to my videos. If you want something, just comment to my videos, and that will be it, right? That will be it. So thank you very much. Don't forget to subscribe.